Hello again, everyone. Welcome back to another section of intermediate algebra. Today we are in section 7.3 and we're going to be talking about least common denominators for rational expressions. So we're getting ready to add and subtract rational expressions, and that's coming in section 7.4, but right here in 7.3 we just want to talk about how to find the least common denominator. So we'll be finding the least common denominator for a list of fractions, and we will be practicing writing equivalent rational expressions. Let's go ahead and get started. Okay, first of all, as you know from adding and subtracting regular fractions that don't contain variables, adding and subtracting fractions requires a common denominator. You can only add and subtract fractions if the denominators are the same. Now, just for the sake of convenience, we like to use the smallest possible common denominator, and that's called the least common denominator. Least because it's the smallest, and we usually abbreviate least common denominator as LCD. So here are the steps for how to build an LCD. First, you need to factor each denominator into prime factors, and then you're going to list each different denominator factor the greatest number of times it appears in any one denominator, and you put those together in multiplication form. Now it says multiply, but we won't actually be multiplying as in distributing and combining terms. We will leave them in factored form, but they are written in a multiplication form. So we'll practice here. First, like we did in the last couple of sections, we'll just practice on regular fractions, and then we'll take that to rational expressions that contain variables. So we have here 1 over 24 and 7 over 15. Now notice the comma. It's not asking us to add. It just says find the LCD. So let's take the first denominator, which is 24, and let's factor that into prime factors. Of course, 24 is 4 times 6, and of course 4 can be broken down into 2 times 2, and 6 can be broken down into 2 times 3. So 24 is 2 times 2 times 2 times 3. And then 15 is just 3 times 5, and both of those numbers are prime, so no further breakdown is possible. Okay, now we're going to build our LCD. So the rule is we list each factor the largest number of times it occurs in any one denominator. So I'll start with the 2. I have 3 2's in this list and none in this list. So the largest number of times the 2 occurs is 3 times. So I put down 2 times 2 times 2. And then I'll go to the 3. The 3 occurs once here and again here. The largest number of times the 3 occurs in either list is 1 time. So I'll put down the 3 once. And then I have the 5. I have a 5 here and none here. So the largest number of times I have a 5 is once, so I'll put down the 5 once. And now, since these are all numbers, I'll go ahead and multiply these together. 2 times 2 times 2 is 8, and then 8 times 3 is 24, and then 24 times 5 is 120. So the least common denominator for 24 and 15 is 120. Now that's all we're going to do here for part A, because that's all the instructions asked us to do. So let's go on to part B. Our denominators in part B are 8x and 10x. So let's start with the 8x. We need to break this down into prime factors. Of course, 8 is 4 times 2, and 4 is 2 times 2. So the 8 breaks down into 2 times 2 times 2, and then we also have this x. And then for the 10x, 10 breaks down into 2 times 5, so we'll have 2 times 5 times x. Okay, so we have the prime factoring here for each denominator. Now let's build our LCD. So we have 3 2's here, and then 1 2 here, and so we'll put down the 2 3 times. So we'll have 2 times 2 times 2. Now let's do the 5. I have no 5's in the first denominator, but I have 1 5 here, so I'll need to put the 5 down once. And for x's, I have 1 x here and 1 here, and so the largest number of times the x occurs is once, so I need to put an x down once. So now I have 2 times 2 times 2 times 5 times x. That's our common denominator. So let's multiply the constants together. 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40. So we have 40 times x. And that's our LCD for part B. Okay, here is another example. So we'll find the LCD for 5 over 6r squared and 3 over 4r to the third. So let's start with our first denominator, which is 6r squared, and we'll break down the 6 into 2 times 3. So this denominator has factors 2 times 3 times r squared, and we can just leave the exponent on that r, that's fine. And let's look at the second denominator, which is 4r to the third. So 4 breaks down into 2 times 2, so we have 2 times 2 times r to the third. And now let's start building our LCD. So first let's look at the 2's. I have 1 2 here and 2 2's in the second denominator. So I'll need to put the 2 down twice because that's the largest number of times the 2 occurs. Of course, 2 times 2 is 4, so I'm going to go ahead and write 4. And now let's look at the 3's. I have 1 3 here and no 3's in the second denominator. So I need to put the 3 in my list one time. And then for the variables, I have 2 r's here and 3 r's in the second denominator. So I need to put the r down 3 times. In other words, I need r to the third. So for each factor, I have it down the largest number of times it occurs in any one place. And so, of course, to get our final, 4 times 3 is 12. So this LCD is 12r to the third. All right, now in example 3, we're getting into some denominators that are more than one term. So they're not just monomials anymore, but we will still find the common denominator the same way. So let's start with part A here. So we have our first denominator 5m, and that really can't be factored. But the second denominator is m squared minus 3m. So we see here that we have a GCF of m. So let's factor out that m. That's going to give us m times m minus 3. And now we can build our common denominator. So for the common denominator, first we see that we have 1 5. So we'll put down a 5. And then for the m, I have an m here and 1 m here. So the largest number of times the m occurs is once. So I only need to put down m one time. And then I need a factor of m minus 3. So this is our common denominator. And notice that there's no need in distributing the 5m. It's actually better if you'll just leave it in factored form. Do not distribute. Once you find your common denominator, leave it factored, because we need to be able to see the factors to use it later on. Okay, let's move on to part B. So here we have 3 different denominators. We'll start with this first one, and this is a trinomial, so it's going to factor into 2 binomials. R squared is going to break down into r times r. The signs in our binomials need to be different because of this minus sign, and last times last is 5. So we pretty much have to go with 5 times 1, but let's put the 5 with the minus sign and then the 1 with the plus sign. That way outer plus inner will add up to negative 4r. Okay, moving on to the second factor, r squared minus r minus 20. Again, that's a trinomial. It's going to factor into 2 binomials. So r squared is r times r. The signs in the binomials need to be different. And last times last is 20. So you're probably already thinking 5 times 4. And let's put the 5 with the negative so that we can get that middle term to add up to negative 1. And now you can check it. Outer plus inner is 4r minus 5r, and that does make negative 1r. And now our last trinomial. So again, that's going to make 2 binomials. First times first is r times r. The last term is positive, so that tells us that the signs in the binomials must be the same, and they must both be the same as the middle term. So we have minuses here, and then 5 times 5 is 25. And you can just check to make sure that outer plus inner adds up to negative 10r, and it does. Okay, so we have all of our factors here now, and we're ready to build our common denominator. So in the first denominator, I have an r minus 5, and I only have 1 r minus 5 in the second denominator, but I have 2 r minus 5's in the third denominator. So I'm going to put the r minus 5 down twice. And now let's look at r plus 1. I have r plus 1 here in the first denominator, but not anywhere else. So I'll need to put the r plus 1 down one time. And then I have an r plus 4 in the second denominator, so I'll need to put that down one time. So our final LCD here is r minus 5 squared times r plus 1 times r plus 4. And again, we are not required or even expected to multiply all of this out. It is best if you leave it in factored form. Here is part C of example 3. So here our denominators are q minus 5 and 5 minus q. Now, I'm sure you notice that these are opposites, and there's only one factor here. So for the first denominator, there's no factoring to do. The only factor is q minus 5. For the second denominator, that's the opposite of the first denominator. So we don't want to treat it as a totally different factor. What we want to do is factor out a negative, and that lets us change the order of the subtraction. Remember how we learned to do that back in section 7.1? Now when we build our LCD, we see that we have a coefficient of -1, so I need to put that down. And we have a q minus 5 here and also here, so I need to put the q minus 5 down one time. And that's our common denominator. That's it. Now that we know how to find a common denominator, what are we going to do with that common denominator? Well, once the LCD has been found, the next step in getting ready to add or subtract the fractions is to rewrite the fractions so that each fraction has that same denominator. You've always done this since elementary school when you add fractions. So this won't be too much of a stretch for you, but let's just practice it. So in example 4, it says, writing equivalent rational expressions, write each fraction as an equivalent expression with the indicated denominator. So here they have 3/8, and they're saying that equals how many 40ths. So pretty much they're giving us the new denominator. We don't have to find a common denominator here. All we're asked to do is find out what would be the new top number. So let's look at it like this. If we have 3/8, we're going to multiply by 1, something over itself, in such a way that we end up with 40 in the denominator. So you have to ask yourself, 8 times what makes 40? Well, of course, 8 times 5 makes 40. But if you multiply the bottom by 5, then you need to multiply the top by 5 as well. So let's put 5 in both spots, and then 8 times 5 makes 40, and 3 times 5 makes 15. So we see that 3/8 is equivalent to 15 40ths. All right, that's for part A. Let's look at part B. So here we have 9k over 25 equals how much over 50k? So again, the 25 gets multiplied by something that produces 50k in the denominator. What would I have to multiply by 25 to end up with 50k? Well, 50k is going to need to be 25 times 2k. So that's the part you have to think up. 25 times 2k makes 50k. So you know what denominator you're shooting for, and you have to figure out what goes here. And then whatever goes here also goes in the top as well. So if I multiply the bottom by 2k in order to get the denominator that I want, I also have to multiply the top by 2k. Okay, now 9k times 2k is going to be 18k squared. So notice that 9k times 2k is 18k squared, and 25 times 2k is 50k. So that's how we get the new numerator. Whatever we multiply by in the bottom that gets us the denominator we want, that's what we multiply into the top. So let's kind of sum up what we just did. If you need to write a rational expression with a specified denominator, then if it's not obvious like it was in the last couple of examples, you'll need to factor both denominators, the beginning fraction and the fraction that you're trying to get to. And then you'll decide what factors from the target denominator are missing from your first denominator. And whatever's missing, multiply that into the denominator, but you'll also have to multiply it into the top. and multiplying top and bottom by the same thing does not change the value because anything divided by itself is 1. So basically we're just multiplying by a big fancy 1. Let's practice that here in example 5. So it says write each rational expression as an equivalent expression with the indicated denominator. Okay, we have 8 over 3x plus 1 equals blank over 12x plus 4. So it's our job to figure out what we have to multiply by here, but it's impossible to do that until you factor the GCF out of this second denominator. So this first denominator can't be factored, but the second denominator can. So if you look at this, you notice there's a GCF of 4 here. So let's undistribute that 4. So 4 times 3x would make 12x, and 4 times 1 would make 4. So we see that this denominator factors into 4 times 3x plus 1. Now, we started with a 3x plus 1. So what do we need to multiply by to achieve this? So of course I need to multiply by 4. And if I multiply by 4 in the denominator, I'm going to need to multiply by 4 in the top. Okay, so the new top is going to be 8 times 4, so that's 32. So we see that 8 over 3x plus 1 is equal to 32 over 12x plus 4. Can you see it? If you multiply this denominator by 4, you get this denominator. And if you multiply 8 by 4, you get 32. So top and bottom were both multiplied by the same thing to get this new fraction. Okay, let's try it again with part B. So here we have 12p over p squared plus 8p. And we're asked to get a new fraction where the denominator is p to the third plus 4p squared minus 32p. And that looks so complicated. But once we get both of these denominators factored, we'll be able to figure out what's missing, and we'll know then what to multiply by in order to get our new top. So let's start by factoring this first denominator. So I noticed that this denominator has a GCF of p, so I'm going to factor out or undistribute, so to speak, that p. So of course the top stays 12p, and in the bottom we're factoring out a GCF of p, so we're going to have p times p plus 8. Because p times p is p squared and p times 8 is 8p. Okay, now we know that we'll have to multiply this by some currently unknown factor in order to get this target fraction. And in order to figure out what goes here, we'll have to see this denominator in factored form. So let's come down here and do some scratch work, and we'll take that polynomial that we're starting with, and notice that it has a GCF. Notice that every term contains p. So we first need to factor out the GCF of p. So we're undistributing that p. So that's going to be inside the parentheses p squared, because p times p squared is p to the third. Then our middle term, we need a 4p, because p times 4p would be this 4p squared. And then we need a minus 32 to create that last term. Now notice that this is a trinomial that can be factored into two binomials, so don't lose your GCF, but take this trinomial now and break it down. So p squared is p times p, the last times last is negative, so we need different signs in the parentheses, and then 32 can be 8 times 4, and we'll put the 8 with the plus sign in order to get that positive 4 as our middle term. So this is the factoring that we're after. Okay, now let's compare. We need p times p plus 8 times something to give us this. So what's missing from here? What do we have here that's missing from here? And of course the answer is p minus 4. So I need to multiply the bottom by p minus 4 to get that denominator, and therefore I also should multiply the top by p minus 4. Okay, so what do we have? This original fraction, 12p over p squared plus 8p, equals this times this in the top. So 12p times p minus 4 over that denominator. Notice that I didn't even distribute the 12p into the p minus 4. It's not necessary. You can just leave it in that factored form for what we're working on right now. Unless the instructions tell you otherwise, it's okay to just leave it in factored form. And that's it, guys, for finding common denominators. Now, it does take a little practice, and it does take some skill with factoring, but this is a good chance to work on your factoring skills and to keep developing those. And I just want to encourage you, because this is a place where a lot of students get a little bogged down and maybe get a little discouraged, because this is all very abstract. You know, we can't compare this work to apples and oranges and things in the material world that you can relate to. This is all very abstract. And so it's a good thinking exercise. Keep working on it. Don't let it bother you that you can't feel it and touch it. Just keep thinking about it. That's how you develop thinking skills. So practice with it and ask questions when you need to, and don't procrastinate. All right, and I'll see you in the next section.